Thank you so much, everyone. And I mean, I have a completely different type of presentation today. And I mean, I've been very inspired by previous presentation. I will give you my perspective on like embodied intelligence and more or less like what has been my journey and what I'm trying to achieve so far. So, of course, I started with the idea of trying to like allow robots to have physical interaction with the world and safe interaction with humans. So and so moving them from an environment that is usually constrained and where they have to perform well-defined tasks with limited behavior diversity to make them able to deal with unpredictable environment and be very flexible and be able to accomplish very different tasks. So to do so, I started my journey by trying to design and develop artificial skin for robots, so providing them the ability to interact with the environment. And I think probably some of you already maybe had the opportunity to saw this sensor around. So the idea was to actually solve a lot of technical challenges that are related to the development of this system and scale up from a small tactile sensor to actually be able to cover up to 2 square meters of surface of the robot body. And definitely was not an easy task because required to find trade-off among several problems like related to the portabilities of this sensor to several systems with different kind of body, let's say morphology, and but also wiring and data handling. And here you can see that like we were trying actually to be able to cover several robots with this kind of technology. And the first type of the first type of application that we were trying to achieve was, of course, interaction with human and the tactile-based control. And here you can see more or less the response of the sensor on when integrated on a robot, and the fact that it responds to pressure that is applied on the robot body and can provide up to 16 bits of pressure resolution. And this actually allows us to achieve behavior like this one, that is a completely reactive behavior. So here there is no planning, no vision involved. And the robot actually knows only where he needs to, the point that he needs to reach, and doesn't have any knowledge about the environment that is in front of him, but just use the tactile sensing ability to navigate this cluttered environment, trying to reach the point. And so this was like things that can be enabled from by having like tactile sensing ability on the robot body. But I started after to look at the to look at another perspective. And so I mean at the fact that we need, so if we look at biological organism, of course we have compliant body, and this allows them to be able to deal with a very difficult environment, and soft robotics definitely can allow us to achieve better and simple mechanism, exploiting the mechanical intelligence of some material. But I like looking at the problem of the sensing perspective, like a question arises about, okay, thanks to this compliance, we can actually have a system that can be very adaptable and can actually sort out some tasks just thanks to their morphology and compliance of the body. So do soft robot need sensor, because it looks like that without any complex control and without sensor, they can definitely be able to accomplish tasks and be very, very adaptable. But of course, like there are some situations in which we wanted to be able to provide a robot with sensor, even soft robot with sensor, and of course, when this comes from the problem of control them in difficult environment, and so here we were looking at the problem of controlling, for example, a soft arm in again in a cluttered environment, and precise control, of course, require to be able to first of all estimate the posture of the robot, and so provide the robot with proprioception, and that is something that we started to look at, because of course these require to solve some challenges even in from technological perspective. So how we can estimate the posture of the robot that theoretically has infinite degrees of freedom without, first of all, by having an integration of sensing that is robust and reliable, also without impeding the or impairing the compliance adaptability of the system. And so here we were trying to sort out this problem by trying to estimate the posture of the robot by using some distributed pressure sensor at the link of so at the, let's say at the joint of this robot, assuming that a deformation could generate a pressure distribution on top, and so using this information to be able to actually estimate the posture of the robot. But also another problem is providing these robots with also exteroception, and this is also in relation to sensory motor coordination, and so is related to the problem, to the perception problem of the robot. So we were actually starting to look at how to design sensor that can be soft, but also that can be able to be tunable online. And here you can see this sensor is just a soft chamber, and we can design it to be able to change its sensory range online by changing the internal pressure of the sensor, and allowing to actually using the morphology of the sensor to in a certain way simplify the perception problem, and this is what we can try to answer, is how we can exploit softness or anyway variable stiffness in the tactile perceptions problem, how we can use also the morphology of the sensor to actually simplify the tactile perception problem, and we use this sensor to actually evaluate how we could be able to tune online the internal stiffness of the sensor, and be able to distinguish between two different patterns in a structure that was actually embedding a soft pattern with high frequency and a more rigid pattern embedded in the structure. And we were like changing the internal pressure with like allow the sensor to be very compliant, so very sensitive or stiff, and we analyze the response in the frequency domain, showing that actually this capability allow us to exploit in the morphology and the tunability capability of the sensor can allow us to actually simplify the perception problem. And we were also trying to now integrate this sensor to like a soft hand. This in particular is a soft hand where we were trying to achieve like an active palm. So we have and also distributed tactile sensing on the whole subface of the hand, and also trying to be able to design and manufacture these hand in one batch. So by using 3D printing, having the hand already equipped with the tactile sensor on top, and be able actually to exploit this sensor also in the problem of in the perception problem. And so here you can see that the hand is like is actuated pneumatically and actually with just 1 degree of freedom. So we are actuating all the joint together, and you can see that thanks to the compliance of the hand, we can achieve a good conformability to different type of objects. And we are now looking at, I mean, how to exploit this compliance and tactile sensor on the hand to be able to, from the tactile perception problem, so be able to do object recognition, but also be able to achieve in dexterous manipulation with this. And I would say that, I mean, sorry, this is it from. Okay, yeah, thank you, Perla. It's very fascinating technologies that you're developing, and yeah, that's totally relevant about the perception of the world. So